So in this video, I'm going to discuss Microsoft supports using Solver for capital budgeting. So in this example, let's suppose we have a company with 9 projects under consideration. The net present value added for each project and the capital required by each is below for the next 2 years. All are in millions. So for example, project 1 will add 14 million in net present value and require expenditures of 12 million during year 1 and 3 during year 2. During year 1, 50 million in capital is available for projects and 20 million is available during year 2. If we cannot undertake a fraction of a project but must undertake either all or none of a project, how can we maximize net present value? And then secondly, suppose that if project 4 is undertaken, project 5 must be undertaken. How can we maximize net present value? So the other data include project 2, 1754.7, project 3 is 17.6 and 6, project 4 is 15.6 and 2, project 5 is 40, 30 and 35, project 6 is 12, 6 and 6, project 7 is 14, 48 and 4, project 8 is 10, 36 and 3, and project 9 is 12, 18 and 3. So then in my next sheet here, I have set up the data. So let me zoom in. So for the first question, we're going to ignore the 4 and 5. I will come back to that more specifically here in just a moment. What I did is I put the data in, so you can see there from A1 I just put project, I labeled everything, and I've included E1 here that's include. So basically how this is set up is this tells me which project I accept. 0 is no and 1 is yes. Then I've totaled everything up beginning in row 11. So A11 I put total. And then a formula I created in cell B11 is equal to sum product of B2 to B10, comma, E2 to E10, and that's fully anchored, so your dollar signs on everything, because basically I'm multiplying the E column by the B column. So if it's included, the total net present value will increase, and if it's not, then it will decrease. And then I've got my year 1 cost. I've done the same thing, so I just drag that over. So there's my year 1 cost, and then my year 2 cost. So my constraints, obviously I'm trying to maximize net present value, and the Y1 cost is 50 and the Y2 cost is 20. So obviously that's how much money I've got for each year. So initially when I set the problem up, let me go to Data Solver, and note that if Solver is not available to you, you'll need to go to File, Options, you'll need to go to Add-ins, click Go on your Excel add-ins, and then Solver add-in. Make sure that box is checked. Okay, so coming back here, making sure that's now in their Data Solver. And then your constraints will be, we're going to set the objective B11, we're maximizing net present value. And then we're going to change the variable cells, the include column I made here. So those will change. And then it will be subject to the following constraints. Let me delete this one. I'll show you that one in a moment. So my constraints are going to be as follows. Go into this one first. So you'll click Add Constraint. I'm just going to change these to show you here. So I set E2 to E10 to be equal to binary. It will be 1 or 0. So drop down here, make sure that's bin, and then that will populate. Click Add Constraint, or you can go back in here and add it from here. And then the next one will be this one. So showing you this one. I have C11 to D11. They have to be less than or equal to C12 and D12 respectively. And then this is a simplex LP. So I'm going to make unconstrained variables not negative. You can go in here and change options if you want to, but I usually just let it be and see if it will work. So now I'll click Solve. And Solver has found a solution. So you'll see here that the net present value is maximized at 70. The year 1 costs 48 and it's below 50, which is good. And the year 2 cost is exactly 20. We choose projects 1, 3, 4, 6, and 9. And the second part of the problem specifically said that if you choose 4, you have to choose 5. Okay, so we've chosen 4. So now I need to go in here and choose 5. So what you should immediately notice, let me zero all these out and show you what happens if you did that. So the biggest reason why we didn't initially choose 5 is because its cost is very high. So it does give us high NPV, but the year 2 cost is 35 according to the data. And then just confirming the data we got there, it is indeed 35. So we would never choose this project. But let's suppose you didn't know that. So how could we set this up in Solver to do this? So what I did is I just typed in 4 and 5 here in cell A13, and then in cell B13, I've set it to be equal to the sum of E5, D6. And I'm going to add a constraint that says, hey, if you choose 4, you have to choose 5. So those have to be, we'll just try it and say that has to equal 2. So let's see what happens. So I'm going to add the constraint that says, hey, this has to equal 2. Then click OK. And then I'm going to click Solve. And you'll see that Solver could not find a feasible solution, so I'm going to cancel. So now what I'm going to do is go back into Solver and say, hey, well, if we can't pick both 4 and 5, then let's just say that that number has to be equal to 0. So we'll pick neither one. And solve again. And now we'll say that Solver has found a new solution that doesn't include 4, doesn't include 5, and now it's projects 1, 3, 6, and 9. So then I didn't show the scenario summary for this one, but there's other videos there for this. But one thing going back to the Solver is once you solve for something, you can save it as a scenario. So you can just click Save Scenario and put in your name. And I did that, and I'll show that here for the other ones. So you can do a scenario summary that shows you. And I went in here and edited this a little bit. But if you go to Data What If Analysis Scenario Manager, you can create different scenarios. You then merge them and say, hey, what data you want outputted, then summarize it, and it will do this for you. Like I said, you can check out other videos that I've done for that, but here we can say, here's what happens. So both 4 and 5, that is a fail. You can't do it because as I demonstrated the cost, so that one, the red one here, wouldn't even work. So if I'm able just to maximize NPV, I would choose projects 1, 3, 4, 6, and 9 for an NPV of 70, and year 1 cost that's $2 million below the $50 million available, and exactly hits the year 2 cost. But if I cannot choose, obviously we already saw we can't choose 5, so that means we couldn't choose 4. So if that were the constraint, then we would have to drop 4, and we would just only choose projects 1, 3, 6, and 9, yielding a highest NPV of 55, a year 1 cost still below 50 at 42, and a year 2 cost now below 20 at 18.